Hey everyone. So we are done astronomy. Congratulations on finishing your first unit over distance education. It's the first one I've ever taught over distance education. And so we're going to continue on with uh, chemistry. So we had started chemistry before March break. Before we pick up where we left off, I'm actually going to go back and review the notes that you do have. Uh, I realize that I will send these notes to you as well. I do realize that for you, a lot of these notes are probably in your locker, along with a pretty moldy ham sandwich. Uh, I definitely don't want to be opening up any of those lockers in June after months and months of what might be living and growing in there. Anyway, so we're going to get back to chemistry, and as I said, we'll start from the beginning. We'll go through the first few notes pretty quickly because we have been through them already, but I want to remind you of what we talked about, and then we'll start to move on. And I think even by the end of the first week of doing this, that we'll do a lab again. I've been trying not to give you a lot of busy work assignments, just giving you the notes like we would be doing in class and the worksheets. Hopefully you're understanding some of this material. If not, feel free to ask me questions. Send me those questions some of you have already, and I'll answer them for you. And hopefully in this unit, we can do a couple virtual labs, and you can get your marks that way. So first of all, I didn't open up the first note. Basically, the big introductory topic that we had was what is matter? And if we recall, matter is anything that has mass and takes up space. If you've printed these sheets up or if you're writing it down, write that down. Matter. Anything that has mass and takes up space. So your cell phone is matter. It has weight or mass. It's taking up space. You are matter. And you matter too. You have weight or mass and you're taking up space. And even at a microscopic level, when you look at, uh, if you were to zoom in on the tip of a needle, the pointy end of a needle, there are billions and billions of atoms. Atoms are these little tiny pieces of matter. They have weight, not very much weight, but they do have weight, and they take up space. Not very much space. There's billions of them on the end of a needle, but they do have weight and space, and so they are matter. So we're going to be looking at matter a little bit more in this chemistry unit. The properties of matter, though, and this is what we started to look at before. We have physical and chemical properties. So we started with physical properties. And physical properties are basically how can we describe what something looks like? So, I don't know, let's take a quarter. Let's describe it. Well, we can describe its state of matter. A quarter, of course, is a solid. And quarter, I'm talking about the 25-cent piece. If it was a cup of water, we'd be describing it as a liquid. Hardness. A quarter is pretty hard. I wouldn't want somebody to throw it at me. We wouldn't describe liquid and gas with hardness. So some of these physical properties we can use, some of them we can't. The next two, ductility and malleability. So these are only for describing solids. And typically these are only for metals. So malleability, it says they're bendable and brittle. Not so much. Malleability, a better definition is, can it be pounded flat? So if I gave you a big ball of copper, can you with a hammer or can you with a machine, a press, pound it flat? And the answer is yes. If I gave you a big huge ball of aluminum, can you pound it flat? And with a machine, the answer is yes, you can pound it flat, and we get aluminum foil. Other things you can't pound flat. Can you pound a piece of glass flat? No, you pound on it, it's going to break. Can you pound a piece of wood flat? Absolutely not. You pound on it and it's going to break and shatter as well. So malleability is being able to flatten something out. Ductility is along the same lines. Can you pull it out into wires? So can you pull copper, aluminum out into long, thin pieces? Absolutely you can, with a machine, of course. Can you pull glass out? No. Can you pull a piece of wood and make it longer? No, absolutely not. If you could invent a machine that could do that, you'd be a hit in the construction industry for every carpenter who has ever cut a piece of wood too short. But most things are not malleable or ductile. Metals are. Melting and boiling points, the crystal form of it. Crystal form as well. What I often think of crystal form is, so if it's sand or if it's salt or sugar, how can you describe that? So what we're talking about here also is texture. Is it fine, like baking powder? Is it granular, like salt or sugar? Is it coarse, like the salt that we might put down on our driveways and sidewalks to melt it? Is it coarse like a beach? Is it fine sand, or is that rocky coarse sand? Solubility, will it dissolve in water? So if you put salt into water and stir, that salt dissolves, it sort of disappears, we can't see it, it's dissolved. If I put sand into water and stir, it's not going to dissolve. Viscosity is a resistance to flow. Water has a very low viscosity. It flows easy, we can pour water easy. Maple syrup, on the other hand, has a higher viscosity. It's thicker, it doesn't flow as easily. And density. So this is where we weigh something, and we take that mass or weight and we divide it by how much we have, which is a volume, and we get a density. Another way density is thinking of density is how tightly are those atoms, those microscopic atoms, how densely are they packed together? Are they packed together or are they spread out? So these are all physical properties. These are all ways that we can describe what something looks like. So that quarter, it's a solid, it's hard, it's malleable, it's ductile. If we heat that quarter up, we will find that it'll melt into a liquid. So we can find that point. It won't dissolve if we throw it in a cup of water and stir. It's not a liquid, so it's not viscous, and we can calculate the density of that quarter by weighing it and dividing it by how much there is. Chemical properties, we're not describing what something looks like, we're describing how it acts, the behavior of it. And three big chemical properties that many things have are combustibility. Will it burn? Will our quarter burn? Absolutely not. Will a piece of paper burn? Absolutely. Will gasoline burn? Absolutely. Reaction with acid. Will it dissolve in acid? If we put our quarter into a strong acid, will it dissolve? Yes, it will. And will it react with oxygen? Does our quarter react with oxygen? Our quarter is an alloy. It's a mixture of metals that's designed not to mix with or react with oxygen, but many things do. So your bike chain, it reacts with oxygen over the wintertime, and you get a layer of rust on it. This matter, anything that has mass that takes up space, we can group it into two categories, metals and non-metals. So everything in the world is either a metal or a non-metal. And when we mix metals together, we call those alloys. So stainless steel is basically what your quarter is made of, and it's what your knife and fork are made of. It's an alloy. It's a mixture of metals that have been mixed to give it a certain property, and that property is that it will not react with oxygen. You don't want it to rust. You don't want your fork to rust every day. So it's made of stainless steel. Brass is another mixture of metals. Brass will not rust as well. Not only that, but it's resistant to salt water. So brass is quite often used on boats and around salt water because it doesn't react with the salt as well. So just as a review, physical properties is describing what something looks like. Chemical properties is describing how it acts. If you heat up a piece of paper warm enough, it will combust. It will start to burn. If you heat up a piece of wood hot enough, it will start to burn. I think I mentioned in class, when you bring a match to a piece of paper, you are not lighting that piece of paper on fire. In order for combustibility to take place, three things have to be present. One, you need fuel. Paper is your fuel. Two, you need oxygen. There's lots of oxygen in the air. And three, you need heat. So at room temperature, that piece of paper sitting on your desk is not warm enough for a chemical reaction to take place. If you bring a match to it, the flame from that match, what it does is it heats the paper up. And once the paper gets to be a couple hundred degrees in temperature, then a chemical reaction will start to take place. The oxygen in the air and the paper will undergo a chemical reaction. And that chemical reaction, we see that in the form of heat and light. So we see the flame and we get a heat off of the flame. That's what's happening there with combustibility. Moving on to physical chemical changes. So we've described how things look and how they act. Let's look at the changes. So a physical change is the substance stays the same. So if I rip a piece of paper in half, it's still paper. I've changed the size of it, I've changed the shape of it, but it's still paper, both pieces. If I melt ice and it turns into water, that's a physical change as well. It's still water molecules. I don't have something different. I don't have a nail. I don't have baking soda. I still have water. It's changed state. If I put sugar into water and I stir, nothing happens. I don't get anything new. What we have is sugary water. The sugar is in there and it's still sugar. The water is in there, it's still water. So that's a physical change. A physical change is anytime you don't get something new. You don't get new paper, anything new when you rip something. You don't get anything new when you put sugar in water. And most physical changes are easy to reverse. I say most because not always. If I stir salt into water, I can take that salt back out of the water. All I have to do is boil the water's gone, and I'd be left with a pot full of salt. I can reverse that dissolving. If I cut a piece of wood in half, I can't reverse it. I can't put that wood back together. Yeah, I know, glue, tape, staples, whatever, nails. All you're doing is holding two pieces of wood really tight against each other. You haven't actually put it back together. So cutting a piece of wood in half, ripping a piece of paper in half are not reversible. We went over this chart of just the different terms for moving between the different states of matter. Now, chemical changes. This is where we get something new. So if I burn something, if I burn a piece of paper, that's a chemical reaction. I told you about that already. We get something new. We get smoke. We get water. We get carbon dioxide. We get carbon monoxide. These are all new chemicals that were not there before. Cooking. If I put flour, sugar, water, these things, an egg together and put them into the oven, I can make a cake. That cake is something new. It's not flour anymore. The flour's gone. It's not sugar anymore. That's gone. The egg is gone. It's not egg particles anymore. They've all reacted with each other and we have something new. Likewise with rusting. We have an iron nail. We have oxygen in the air. Those things react. The oxygen's gone. Some of the iron atoms or particles are gone and we have something new. We have rust particles. It's a whole new thing. Now, how do we know if we have something new? Because we can't always see it. Some of the clues that we look for. Do we get a new color? So rust is a new color. The black carbon, when I burn something, that's a new color. When I cook something and it browns up, that's a new color. Heat or light are given off. When you burn something, it gives off heat. It gives off light. We see that in the flame. That tells us there's something new. When I bake bread and that bread rises, when the yeast reacts, it forms gas. And I can see where those gas bubbles have been. When I cut my bread open, I can see where all the gas bubbles were. A precipitate forms. This is where you put two liquids together and you get a solid. It actually forms something new called a solid. And the fifth one is not difficult to reverse. The fifth one is a change in odor. You bake bread, you know that a chemical reaction is taking place because of the smell. So these videos can only be 15 minutes long. I'm coming up to the 15-minute mark right now. So I'm going to pause and start a new video for you.